And because I am technologically challenged, okay, I've just given you that. I've just done that.
No, you've just started sharing your screen.
Oh, have I just
so
shared my
I think
screen?
you need. Yeah, if you come out of that, I'm trying to remember how to do it. I haven't done it for a while as a host, having to do this. Can't remember. Does anyone remember on Zoom?
What's are you can see share screen on the bottom. What are you looking for?
Yeah, when I press it, it says host disabled attendee screen sharing, so I can't share my screen.
So then Mandla still is the host. And you had Mandla, you still have to give, so if you click on Vicky's name on the top right at participants.
Okay. Yes.
Drop, it should be, you should be able to right click on it, I hope. Oh, I'm talking, yeah. I think if you click on her name, it should be able to make, you should be able to make a host.
Okay, okay. Allow it. Okay. Ah.
Okay, so if you stop sharing your screen, Heather, then I can hopefully share mine.
Okay. So I need to stop sharing my screen.
If you click on ending scratch at the top, if you wiggle your mouse, you should be able to see like end sharing screen or something.
Yeah, I hope you're winning, Mandla. Or alternatively, I can reclaim the host position.
Please do. I'm very challenged here.
Oh.
But it's recording. Oh, but yeah, it's not recording Vicky's screen. Let's see. Now, how do I'm reclaiming the host now, so I'm back to being the host.
Yeah.
And then I go to Vicky, right? Settings, more, allow. What do I say here, Vicky? Again, do I say allow to record local files? No. I don't have to make you a host, Vicky, right? Or can I?
You can make me a host. Yeah, it's fine. I promise not to do anything.
No. Let me make you a host so that you can record. All right. Let me do that. I'm doing that now.
Okay, thanks.
All right. Thanks, Josie.
So.
Okay, I should
that's
my screen now.
So okay, now you're the host. All right. So let me continue my driving.
Cool. Thanks, man.
All right then.
Okay. So hopefully you can see my screen.
Yes.
Is that right?
Yeah.
Okay, let me just get my notes up. 2 seconds. Okay, right. I'm good to go. Okay. We're good. So, yeah, thanks for joining me today, this afternoon, where you are. Oh, it's this afternoon where I am now. Yes, I'm going to talk to you about aquatic animal welfare. Before I do, I'm just going to quickly mention THL. So I'm in the UK. Oh no, hello. Sorry. Oh, technology is challenging us today, isn't it?
Mm-hmm.
Yeah, back to screen. Go back to the first screen. Okay, we're going to start again. Pretend you never saw that. Okay. So, yeah, I'm in the UK and I'm the managing director of the Humane League in the UK, and we have 4 different offices. Well, we don't technically have offices, we're an entirely remote organisation, but we're also based in the US, which is where we originated from. We're in Japan and also in Mexico. I've been working here in the UK for nearly 5 years now, predominantly working on ending cages for hens and now working on improving the welfare of chickens reared for meat. And we've got major food companies to commit to cage-free and to the Better Chicken Commitment, and have big names kind of signed up like KFC and Sodexo and such like. But today I'm going to talk to you about fish, which is a new passion of mine. A few years ago I didn't know a huge amount about fish, but now I do sort of know a little bit. There is so much to know. Every country is different. Makes chickens look very simple. Not that they are simple. We know chickens aren't simple, but it does make them look more simple in terms of having to work with them. So, as has been mentioned, we exist to end the abuse of animals raised to food. And I'm just going to talk a little bit about fish now. So, there are many myths out there about fish. I'm going to talk through a few of them today, not least the 3-second memory, but I know that you will all know that that's not true. And I really hope that I can show quite how incredible these animals are, but also how much work there is to be done to improve their welfare and where we're at right now. One of the facts I found incredible was that we've actually only explored 5% of the oceans to date. So we've kind of got a long way to go before we understand nearly as much as we do about land animals. And there are actually over 33,000 species of fish. That is more species of fish than there are of mammals, birds, reptiles, and amphibians combined. And of course, there's the two ways of looking at evolution, which has kind of led to what we see with this treatment of animals generally. There's this Christian Aristotle view that kind of puts man at top and maybe you'd have angels above them, with this step ladder upwards of evolution, or not necessarily even evolution, but that kind of looks at animals as a top ranking, and then you have these lower vertebrates and higher vertebrates, and it splits them out. And there's no real scientific meaning there. It's just been the way that thinking has developed over time. But actually evolution is much more this tree with the branches. And I really love this kind of concept because I think it makes so much sense that we've all branched off and all have our own niches, and all living species kind of sit somewhere in the tree and have evolved for their niche. And I think it's really important to think of that when you think about fish and you talk about fish, because it really is that case of taking away, like, well, this evolved here and then stopped evolution, and this evolved more and more evolved more. That's not what's been happening. It's been a refining process over time. And that gradual refinement has led to these niches and fishes and what they can do and what we can't do, but they can do. Take the anglerfish, not the prettiest that you've ever seen, but they live in almost complete darkness. And to find their mate in complete darkness, as you can imagine, would be pretty tricky when you've got the sea and the ocean, particularly when the male is only half an inch long. So what actually happens is the female finds the male, and the male latches on permanently to the female. Doesn't matter where they latch on, as long as they find each other. They permanently fuse, and then they share blood supply and nutrients and fertilize each other. And he will fertilize her intravenously. And so the female may end up with 3 or more males attached to her like this, but it's kind of a great example of the evolution and the incredibleness of fishes. When people talk about fishes and their brains, and they often say they have very small brains compared to their size, it must mean they're not very intelligent. But actually, when you think about water, you realize it's 800 times denser than air. And because of that, there is a reduction in the pull of gravity. And so the buoyancy effect frees animals up from this issue of weight that us terrestrial animals have to consider. And it's for this reason that the largest animals on Earth, the blue whale, are in the ocean. And it's why the brain to body weight ratio, the smaller brains for the body size, has been used against them. Fish have powerful muscles that propel them through water, as water is so much more resistant than air. And so their weight is not a premium on the limiting body size to brain ratio. Take this squid, for instance. They've been shown to complete a maze quicker than a dog. Now, sadly, there are still questions around fish feeling pain. There is still some scientists in Australia that like to propagate this misinformation. But it's really important to understand the brain and how they work. And so the human has the neocortex, and we see those in all mammals. But birds do not have a neocortex. In fact, they have a paleocortex. And the traditional view was the bird's brain evolved and elaborated on the older structure called the paleocortex, which is still present in the mammalian brain, but underneath the kind of newly layered neocortex. And it's well recognized that mammals, if mammals are conscious, so are birds, I think everyone would say that, but with cognitive feats such as using tools, remembering locations, categorizing objects, and vocal recognition, birds therefore lay waste to the idea that the neocortex is necessary to be conscious. And it's been said that to suggest fishes cannot feel pain because they don't have sufficient anatomy is like arguing balloons cannot fly because they don't have wings, or that humans can't swim because they don't have fins. The fish's answer to the neocortex is the pallium, which is extremely diverse and complex. And while it has kind of less computing power than the average primate neocortex, it's increasingly apparent that it functions for fish the way the paleocortex does for birds, or the neocortex does for mammals. Take this study of a zebrafish that would pay a cost for pain relief was conducted. And so they injected acetate, which is painful, into the fish, into the zebrafish, and they also injected saline, which isn't painful, as the control fish. Now, zebrafish prefer to be in an enriched environment over a barren tank, and they will always choose to go to that enriched environment if they have a choice. When they were injected with that acetate, the painful stimulant, in the barren tank, they would receive a sedative that would relieve the pain in the water, while those with the saline would just choose to go to the enriched tank. And that choice indicates that active need to relieve pain, even when their preference for an environment will be the other tank. And the senses of fish, like humans, vision, smell, hearing, taste, and touch, are all experienced by fish, but different animals have different sensory equipment. We know, like, take owls, they use sound and vision for prey, whereas bats use echolocation, and moths will use sort of vision and smell. As fish have evolved in water, they have no need for eyelids or eyelashes for that matter, and that matters when it comes to people relating to fish. So it's been shown that people find it much easier to be empathetic to animals with eyelashes, as we have, as babies have, like baby animals have, pigs or cows, and they do find it much harder to relate to chickens and fish because of this. And fish go even further, because not only being seen by most of the people, the only time people see fishes is when they're on their plate as a whole fish. And look at the eyes on this fish here. So fish have the ability to work their eyes individually. So fishes like seahorses, gobies, flounders like this one can completely rotate individually of each other. And they have this two fields of vision process. And in fact, this flounder fish is born vertical, but moves to horizontal and then lies on the seabed as it matures. And it's the eye actually like navigates itself over so that both eyes are on one side of the fish. Okay. And their vision is similarly that you can train goldfish to discriminate black triangles from black squares on a white background. So then if you present them with this Kanzia triangle, they will perceive a triangle and a square respectively as a human would, and they will also complete an incomplete picture. So, and it's not really just goldfish that can do this, it's just those are the ones that have been tested. They also have really sensitive to sound. They have super sensitive hearing, and any noise can damage the delicate hairs in their hearing apparatus. So off the coast of Norway, the air gun used for oil searching decreased the abundance of catch rates of cods and haddocks in the area. And what we might hear as a whistle, they can actually detect as rapid pulses or sound like individual beats. And fish can tell sounds originating from directly ahead or behind or below or above. And like land animals, they use noise to communicate. So red belly piranhas will make hitting noises. They may grind their teeth as a way of communicating. Sounds can be made using their swim bladder as well. Anecdotally, there have been stories of people communicating with their pet fish. So, for instance, there was a researcher in DC in Washington for rescue goldfish, and she said they would go to the surface and lip smack to say they wanted food, or when they wanted attention, they'd hit their tails against the wall of the aquarium. And when she went over, they would stop doing that. Salmon have an incredible sense of smell. The sockeye salmon can smell a shrimp at a concentration of 1 part per 100 milliliters in water. That's like 5 tablespoons in an Olympic-sized swimming pool. And sharks have a sense of smell of 10,000 times stronger than humans. So eels, like salmon, migrate and use the scent gradient to get there. And salmon are born in rivers. They go out to sea. They live out there for a few years, and then they come back to where they were born. And they navigate that using 2 or 3 sensory tools. They use the electronic magnetic field. They use the chemistry of the water, so they can follow the smell gradient and retrace the odor after several years of not ever going there. And they'll also use sight as well. Salmon are really strongly motivated to breed where they're born. It's a really incredible feat. And of course, we have to think about salmon farming and what does that mean then when you have salmon that can never do these behaviors that they wish to do so strongly. And the lateral line on a fish is a fantastic adaptation that allows the fish to shoal and move away from each other. And it's a specialized line that you can sort of see indented in the fish. And that allows them to be able to tail water pressure and turbulence from the waves and their own movement. And it's kind of like a sonar system, and it allows them to move more easily in murky water or at night. And we've seen the wrasse, which is a cleaner fish. They are kind of the fish that go around picking off parasites off other fish, much bigger than themselves, in fact. But because it's a symbiotic relationship, they don't have to worry about being eaten. And when the scientists placed a dot on the wrasse, instead of the wrasse thinking, oh, there's a fish for me to clean, instead they realized that it was themselves that had the dot on them, and they instinctively went to clean themselves, therefore recognizing that they had it was their reflection, and the marks were on their own bodies, and it wasn't another fish they were looking at. And this is a great little video of a goldfish that's been trained to kick a football into a net, taught using positive reinforcement as you would teach a dog. They push the ball in and they get the reward. And this teaching method is something anyone can do with their pet fish, and you can actually buy this equipment online if you're interested and you want to teach your fish how to kick a goal. And then they use tools as well. And so this is this video, I'm just going to move it forward to here, shows a tusk fish using a clam and a rock. So throwing the clam that's in their mouth against the rock as a tool to open the clam up. Just give it a second. And again, this is all we would kind of expect as animal welfareists to see, and yet people don't know that these animals use tools. So what does that mean for fish and wild caught fish and those that are farmed? Well, the numbers are going up every year, and it's not the wild capture that's going up, of course, it's the farmed fish that's going up. And the World Bank estimates that 62% of all fish eaten will come from aquaculture. And obviously that aquaculture will be farmed, and that's by 2030. Now, fish account for 1 to 2.7 trillion wild fish are killed every year, and actually 450 to 1,000 billion are killed annually to feed farmed fish. It's very hard to grasp these numbers. I find it incredibly difficult to sort of even begin to comprehend what these numbers mean. But it would mean that fish account for around 95% of all animals slaughtered for food globally. 37 to 120 billion fishes are farmed and slaughtered every year. But let's look at Africa. So fish production in Africa, it makes up currently about 3% of world aquaculture, but it's growing rapidly. And this is because there's been large scale investment, private investment, but particularly in places such as Egypt. As you can see, the numbers are increasing. Egypt produces about 70% of all fish production in Africa currently in terms of farmed fishes. Then we have Nigeria, the second largest, followed by Uganda. Now you can see a couple of those are dipping off, but to be honest with you, it's much for muchness. It's going to go back up again, no doubt. Other countries include Ghana, Zimbabwe, Mozambique, all prime for producing a lot more fish and shrimp, in fact. I'm not going to touch on shrimp today, although we can talk about that at questions later if that's interesting, but I'm just going to stick with fishes. But basically, there's been a 20-fold increase over the last sort of 15 years, and 99% of those are inland systems for freshwater fish, and they are predominantly tilapia and catfish. And that market currently employs 6.2 million people, and some of it is exported, so cold smoked Catfish fillets are exported to the European market. Egypt is actually the second largest producer of tilapia, second to China. It's quite incredible. So we're going to look at some of the different farming systems. You have extensive ponds. These are widely used in rural populations, but that is decreasing as time goes on and production is being increasingly intensified. And the same is seen in Africa, is seen as Asia, is that moving from this predominantly extensive ponds into more intensive production. And in fact, we know that many different farm fishes, in fact, over 400 are farmed currently, different species. Predominantly, it's carp, and predominantly that is in China. China produces an awful lot of fish. But in extensive ponds, there are also fish like carp, catfish, and pike. Carp are herbivores, therefore they're really easy to feed in comparison to some carnivorous fish like salmon or trout. And ponds are maintained in such a way they foster the kind of development of aquatic fauna, and of course, as a consequence, production is generally low, but also the impact is a lot lower. Then you've got these semi-intensive systems that are normally found in lakes and are basically enclosures placed inside the lake. Production is increased beyond the level of extensive agriculture because the food is, they use supplementary feed like dry pellets, for instance. They have higher stocking densities, so you get a higher production per hectare. They're enclosed, obviously they use less energy, they're not going around exploring. And this is typically used for carp, catfish, millet, prawns are obviously rare like this, and shrimp as well. And then you have these intensive systems. And these are the systems that are on the rise. And as human population increases, there's been an increased push for getting getting fish into these systems, out of the natural systems and into these intensive systems. And they're developed to stock as many fish as possible, basically. And this is kind of what one will look like. I've got some more examples. So this is a more intensive system inside. Actually, from the investigation work that I did before doing this talk about kind of African systems, a lot of these typically tend to be more outside than inside, these concrete systems. They're open air rather than enclosed. I think that's probably a lot to do with the climate, because that otherwise bring a whole new element. Whereas, of course, if you're in Scotland, it's very cold and they have to keep the temperature up, so it's a little different. So these floating systems appear to be very popular, used for tilapia and other kind of fish. And then you have these concrete systems which are very popular for the catfish. And so this is, unfortunately for the poor catfish, they are able to cope with very low oxygen levels, which means that they are densely packed. And by densely packed, oh, it's not moving. I mean, once they get to the high stocking density, they're at this kind of level. And these animals, they live for a long time. So when we're talking about tilapia, we're talking 4 to 6 months. And when we're talking about catfish, we're talking 5 to 9 months. We think about a 5-week-old chicken being killed versus the months and months these fish endure in these systems. And there's a lot of welfare issues, as you can imagine, that come with this. So stocking density. It's very hard, I think, for people to understand when we talk to the public about fish, and we've done a bit of work on this, kind of they think, well, fish shoal, so they should be fine with high stocking density, we see them. But actually, that's completely a controlled environment. Shoaling behavior is often for a particular event, i.e. to feed or to escape predation or something like that. They don't necessarily choose when they're relaxed and they're investigating an area to be shoaling. And so different species have a preference for stocking density. The challenge we have is we don't really have the science to show us which species prefers which stocking density, because it's really limited research. And it's really the only last 5 years that we're getting anything where we begin to understand what some of these species may need. But like I said, it's not like chicken where you're like, okay, this is the chicken. Unfortunately, each fish species has its own preference. And not only that, they have different life cycles where they're in this more adult phase. And they want all different stocking densities with that as well. And again, they have different mortality levels then. But what we see as they get older is they often get a lot of fin damage. As they are next to each other, they get aggressive, much like we see with chickens, where they can kind of get bored and become aggressive. It's the same with any species. That's what we do, right? Like, we act out as soon as that's the case, and it's no different with fish. They can struggle with a lack of oxygen. Just because a fish can cope with a lack of oxygen doesn't mean it wants to cope with a lack of oxygen, and I think there's a big difference there, but because they have the ability, we utilize that, but it isn't necessarily something that they want. And again, fish can live in murky water, right? They might have to live in brackish water or whatever it is, but that's a choice. They go in and then they find cleaner water. This constant of being in dirty water with these high stocking densities in their own fecal matter, it's very problematic. So we see these high mortality in these systems, particularly at the younger age, when they're the fry stage, when they're really, really tiny. We're talking about thousands and thousands dying. Now, it is a real issue, and one we don't even really have the stats on. And then there's parasites. And this, from what I can see, particularly in the African system, seems to be the predominant problem of high mortalities, that it's coming down to parasites, be it bacterial, be it these ectoparasites. These are lice that you can see here on a salmon. And that has a huge economical impact, but also has a huge welfare impact on these poor fish. So disease and poor water quality are key issues with fishes. Viruses, which they can be vaccinated against, but of course there's quite a high cost with vaccination that comes in. And then there's the handling that goes with the vaccinations, which is not good. You've got fungal infections that can often happen, bacterial infections, the environmental stress of either temperature, so temperature regulation. If you've got these fish in sea cages, or in river cages like they have in the Nile, when the temperatures get really high in Egypt, and I was working in Egypt at 50 degrees, these fish can't go down as far as they would want to go to get away from that really intense sunlight. Again, these are really big problems. For expansion so much as this feed, and we don't really understand what the fish are experiencing when they're getting poor quality feed, particularly these fish that have now been made to grow a bit faster than they would choose to. Are they suffering from hunger because they're not getting the nutrition they would be expecting to? And then capture and slaughter. So here you can see a number of different ways of catching, but predominantly, particularly in these concrete systems, or in these more extensive or semi-intensive systems, they use these kind of nets to bring them in. You can see in the earth ponds, which are used still quite a lot, particularly in places like Uganda, I think I saw in Ghana as well, they have these earth ponds as well, and Nigeria, that they can siphon the water out, which is a way of catching the fish. The other two are more technologically advanced in the sense that they require a lot of infrastructure, a lot of infrastructure, and they're used on the river systems. So if there's river cages or sea cages, then this is the way that they will capture them through into a boat and into a fish well, into a well of the boat. And so slaughter methods include live chilling. So research was done to see how long it takes a fish to die out of water. They decided they would do the experiment for 2 hours, thinking there's no way that fish will live beyond 2 hours. They did. They were still detecting consciousness in these fish after 2 hours of being outside of water. So fish are often left to die on ice or just left to asphyxiate in air. It's long and drawn out death. A lot of fish are actually having their gills cut while they're still alive. So, you know, it's equivalent sort of to cutting the throat of a live animal, but not as effective or as quick because of the blood vessels and the way it works. So a lot of these fish are taking a long time while they're still conscious, while they're being gutted alive. So percussive blow is really the best way to render these fish unconscious, but if you've got thousands of fish that you're slaughtering at once, it's going to be very problematic, hence the fact they're left to asphyxiate. Gassing, it can't really be used. It's extremely aversive to fish for obvious reasons. They live in water, they're not going to want to be exposed to gases. So the only developed systems that exist that are humane for stunning is for them to either receive an electric stun, and that causes them to lose consciousness, much like with chickens or any other land animal where they do electric stunning, and that can be, and they can be processed and thereby not feel anything when they're being kind of cut into, or you can do it through water with an electric shock as well. So that electric stunning is either to the head or on a sort of, imagine like a layer, like a rotating, I don't know what the word is, I can't think what the word is, but anyway, coming off their belt, they sit on a plate, and that plate moves with the fish so they can catch all these other fish as they go around, and that plate has an electronic stun on it. But the fish really needs to be the right size for the electronic stun. If it's the wrong size, if it's facing the wrong way, it often can go wrong. And then the other way is for the fish to pass through water that has electrics. Now that's a much better way. It tends to be more effective. It's a lot more expensive. But there are some benefits to stunning, particularly for the larger fish, because they see that these animals are easier to deal with when they're actually gutting them. It can be very hard for people to actually handle these fish when they're having to live gut them. So there are benefits that have been seen. And so stunning has really taken off in salmon farming, and it's the largest salmon farming country. They are required by law that salmon must be stunned before slaughter. They're the only country that has that. The other place where there's been quite a lot of work is in the Mediterranean with some of the sea bream and other kind of Mediterranean fish that have now got stunning systems as well. But that's everywhere else, forget it, there's nothing. So I want to show you this video that I found. I thought it was interesting. It shows the harvesting of catfish in Nigeria, and you can sort of see, well, you can see a lot. What they've done is they've drained a concrete pool, which is a classic system for catfish, particularly in places like Nigeria and Egypt. And the fish will lie like this, basically, and then be taken out and I'll just move the video along a little bit. Either die from asphyxiation or from being live gutted. So the worker will now collect the fish and put them into the bowls, and then they'll be live gutting them on the other side. Other issues that go alongside all this suffering that fish endure every minute of the day or when they're being slaughtered is that there's other animals that suffer. So if you've got these open air systems, they are really rife for open air prey. And it's much like we see with kind of other farming systems. If you've got hens or little chicks, big birds will come along and swoop down and take them. In the UK and Scotland, where we have salmon farming, we see salmon farmers shooting seals. And they shoot about 300 a year. I can't really find any stats on birds killing. I know that Egypt has an issue with killing of wild birds as it is. Yeah, it's a big problem, killing the predators that may eat the fish profits. Pollution is a huge problem. And if water aquifers are being used and they get heavily polluted, that can have extremely badly. One of the things that it keeps South Africa from not increasing their fish production is twofold. One, at sea, it's too difficult. The temperatures and the waves and everything else, it's too problematic to have sea cages, basically. And then inland, there isn't the water aquifers. There's such a shortage of water in South Africa that it's not really possible for there to be huge investment in South Africa for fish farming. So while there was quite a lot of infrastructure, it hasn't really taken off in the way that it can take off in other countries like Nigeria. And in Egypt, they're really expanding into the desert because they're using these underwater aquifers and creating these concrete systems. Same as we said in Uganda, in Zimbabwe, in Ghana, they're able to expand much more rapidly. But what's holding them back, from what I've read, is that the infrastructure isn't so great and the availability of feed for the fish is kind of difficult. And so that's been a challenge in expanding fish farming in those countries. Antibiotic use, heavy as you can imagine. Again, it's totally unmonitored, no one really knows. We just know that you farm animals, you give them antibiotics, that's classic. And we know this is probably a huge problem with fish as well. Wild fish being caught. Also, if, wild fish with farm fish. So this is a particular problem with things like trout and salmon, where they have been intensively bred to now produce, to be twice as large as they should be, for instance. And if they escape and they breed with these wild fish, it causes a lot of problems. And then, of course, there's the wild fish that I mentioned earlier that gets caught for the non-herbivores out there. And that wild caught fish is, again, hugely problematic in the way they're caught, the suffering they exist, but also just depleting the oceans as much as they do. Fish farming has a lot of environmental issues that go alongside it. So what needs to happen? We have a number of things that we could do straight away that we know could help. So preventing disease, treating illnesses immediately. Vaccinations, for instance, are key here. Preventing disease means lowering stocking densities. It means having good education of those working with the fishes so they can spot disease early, take out sick animals. Water quality is a key one that can be worked on quite easily. We know good water quality is easy to come by. We know fishes would prefer that. Overcrowding and keep safe from predation. We don't really know what overcrowding looks like entirely with fishes, but we do know that, for instance, those catfish, they're overstocked. Like, they shouldn't be on top of each other. There should be space. And the overarching amount of space as well these fishes get, they're just going around in a circle, like a monotonous circle, no enrichment, nothing. It's a fairly bleak existence for 9 months. So we can reduce stress and injury. What they've found in salmon farming is by giving them more space and creating enrichments in the pens that they have. So they put in like seaweed things that they can nibble at, and then also these sheets that allow the salmon to avoid each other. So if you've got, this is the other thing, like if you've got an aggressive animal aggressing at you and you're just like running in a circle, you can't escape the other animal. But if you've got some kind of shield that you can get behind and hide, it allows some hiding. So that's why fin damage can be reduced. Using more robust breeds, I think, to be honest with you, that's already happening as much as it can. Keeping handling to a minimum. So every time you take a fish out of water, it's extremely stressful, but that has to have handling. So reducing that is important. Improving slaughter requires a lot of investment. It's expensive. Using on-site slaughter obviously can massively reduce things, but what we really need to see is that these fishes are handled as little as possible, kept in water for as long as possible before they're taken out of water, and then when they're taken out of water, immediately stunned, so percussive blow or electrical stunning. It requires a lot of staff training. You want to make sure that obviously once they're stunned, that there's not a long time before the stun to stick time so that these fishes don't come back round. And we really, one of the most basic things we can do is to stop the live sale of fish. The very beginning of this talk, where I talked about a lot about like the fish stories, came from this book, What a Fish Knows by Jonathan Balcombe. If you haven't read it, it's such a beautiful read and I really highly recommend it. It really brought my love of fishes together when I read this book. It's really fantastic, so do check it out. And otherwise, that's everything from me, and I welcome any questions.
Wow, thank you so much, Vicky, for that amazing presentation. I hope all of us enjoyed it, and I find that every time we talk about fish welfare, there's always something new that one will learn, and I think that is also indicative of how much must still be done, in terms of addressing this. Now, colleagues, I'm sure we are a small group, so I suppose we can just unmute and ask any questions that we might have for Vicky at this time. I know there were a number of one or two questions that Brett had already put on the chat. Maybe Brett, you could talk to those questions. Thanks.
Yeah, well, the one is just the practical. Vicky, will you just maybe share some slides? I know it's always just to ask that question. Yeah. And then I think what would be really interesting is just sort of like a very, very condensed version, particularly for like the regions that you mentioned, Africa, Nigeria, and stuff like the country sort of specific ones. That was quite cool. The only, just because like several people have asked in the last couple of days, and I'm certain you probably have heard it 10 times in the last week about Seaspiracy, and also just in general about those types of documentaries, because they're obviously always parallel to the work that we're doing. And I've got, I want to hear your thoughts about mine.
Whether a documentary like that is helpful.
Yeah. So like that, I don't want to put too much. I don't know, maybe it's because it's being recorded. But like, what are your thoughts on those type of more alarmist type things that really get the Netflix people going?
Yeah.
And just some thoughts on that, because like we've obviously just had South Africans like My Octopus's Teacher, which was a very a very different type of documentary, but I think it also had somewhat of an impact. So I just would like to hear what.
Yeah, that made me long for going to Cape Town again. That was such a beautiful documentary. A little octopus. Yes, I think honestly, I think it's a dream when we get these documentaries that can bring people closer to understanding the complexity of the lives these animals live underwater. I just think people can't comprehend it, and we've just recently done some work to see what's people's understanding. Like when we talk about fishes, what do you think? And are you surprised by this and that? And like if you see a fish, we put this imagery up of these fish with their gaping mouths kind of desperately needing, oxygen, but people, they don't scream or anything, so people don't relate to that in the same way. And because people see fishing, recreational fishing, the response we got back was like, well, that's what fish look like. It's because actually, if you think about it, that's kind of the interaction people have with fish the most often, is when they're out of water, gasping for air. It's not even, it shocks me that that's not shocking to people, but that's exactly what the problem is. So I think any of these documentaries that can bring people in and really explain what they're actually seeing, not what they think they've been seeing all their lives as normal, I think will go a long way to us helping. And I really hope we have more documentaries on particularly fish farming, because I think it's a really unknown issue, and it only seems to be the communities that suffer close to these fish farms, like in Canada, for instance, where the salmon farming is really being banned now and prohibited because of the impact it's had on the wild fishes, that's when things start happening. So when I started reading about Egypt, and worked quite a bit in Egypt myself, like I was really interested to understand that. I couldn't quite believe that it's the desert where they're actually increasing this production in an area that I would have thought wasn't really a great area to start putting loads of fish. Is actually using these aquifers is really easy for them to do that. But when we look at aquifers and what can go wrong with the pollution and what can happen with that groundwater pollution, it's really worrying. It's like everything works, everything's fine. If it doesn't work, it's really problematic. And I think, again, that's probably going to be the next exposés, where all this pollution happens in this underwater groundwater. That will be probably the next big thing, I suspect. So yeah, I need to watch. Seaspiracy is actually my thing to watch tonight with my friend. So we're going to watch a little light watch this evening. But yeah, I hope for more. And yeah, we'll see what people's responses are. If it's like black fish, is right, isn't it? Then there's a good chance it will have quite a big impact, I think.
Thanks, Vicky. Are there any more questions, colleagues? Maybe for Vicky.
Yes, Mandla, I've got a question here. I was just wondering, maybe it's because our organization or me myself, I'm new to this aquatic life welfare. I just wanted to ask on the issue on improving the welfare of the fish, where it stated that you have to treat the illness, the disease, or immediately. Does one, maybe from my perspective here in Zimbabwe, where there is fish farming, for me, I think it's very hard. Okay, may I ask, how do you detect that this fish is not feeling well? Do you treat them as a single fish when treating for illness or in detecting, or you just treat the whole pond? That's my question. I'm just wondering.
It's the same problem that we have with chickens and everything. So when you've got tens of thousands of whatever animal might be in a barn or in water in a concrete thing, it can be extremely difficult to spot disease. Probably the first thing you see in fishes is a dead fish floating to the top. Or you start to see, if you look closely, you would see these fishes clearly having, so when they get this bacteria disease, which I think is quite common in Nigeria, they get this bacteria and it causes their skin to go red and raw. So you start seeing these kind of lesions on some of the fish, but there's no way you could treat an individual fish. So when you got pigs, you know, they're big enough and you move them, you should have a sick pen. With chickens and fish, killing ones that are sick, about treating the others before they get sick. And this is the other problem with the antibiotic use. It's not that I'm saying, well, don't ever give these fishes antibiotics, but should we be having these systems if they then require lots of antibiotics to work? No, we shouldn't. But it's a complicated explanation for the public to understand, I think. I hope that helps, Linda.
Yeah, I'm answered.
Okay, so thanks, Linda. Vicky, maybe from my side, I just wanted to check, man, and pick your brain on how difficult is the task that you are taking on as animal welfare advocates of advocating for aquatic animal welfare, considering the fact that aquatic animals are still excluded from the animal welfare discourse. How humongous is this task for us? What would be your take on that?
Yeah, it's a difficult one, isn't it? When I was looking into this, it's really interesting to read about kind of aquaculture in Africa and what's been happening in the investment, and actually how it started. It was completely colonial based. So it was the 1940s, and the Europeans in whatever country they had decided to take over, decided to set up these systems, and then governments kind of invested over time, and they saw it as a nutrition system, and now it's private investment that's happening that's seen this kind of massive growth. Prior to that, kind of governments kept it quite low level. So its origins in itself is not great. And then I was thinking really in terms of what we can do, and what I've been saying about the US, which is not a dissimilar situation. The increase in fish farming is happening inland. So it's taken the limits of increasing the number of fishes we can farm, basically, hence their prediction of the aquaculture going up so much. And in doing so, the US system and what's happening in Africa is this investment in these inland concrete, often concrete systems, either RAS or flow-through systems. And for me, I think the challenge is probably greater to improve the systems we have than to stop like this onslaught of more and more. So I think what we need to be doing in certain countries where we're seeing this rapid increase of inland systems is to try and prevent that. Like, let's try and stop before it explodes into even more investment in these systems. And we haven't found an answer to that in the US yet at all. Not sure whether legislation's the best way to go or anything else, but there's potential there to really stop what could happen, rather than necessarily trying to engage on what's already you can do some of what's already happening. Obviously, I think water quality, like I mentioned, like water quality, even just trying to improve the slaughter conditions, these kind of things could be engaged with. But I think we have, as advocates of animals, a big challenge ahead, trying to get the public to care about fishes, and we already struggle. We're trying to get them to care about chickens, and that is extremely challenging. And we can say a cage and people can comprehend that, versus like, well, there's these fishes in cages in the water, but they have a lot of space, but they don't have a lot of space, and they're all together, but they're not together. You know, it's just like, oh, I think it's really challenging. And my hope is we can stem the tide, pardon the pun, of this increased investment into these countries, because I think that is the future, and that's what's being pushed for. And if nothing else, we can stop the suffering of millions of animals that may happen, even if we can't help the ones that are already in these systems right now.
No, thanks, Vicky. I suppose that it's because then it speaks to this issue of whether, because in Africa, you know, aquaculture is seen as this sort of silver bullet to deal with issues of food security, the creation of employment, you know, and yeah, but then that being the case, you find that then the approach is to then increase and encourage aquaculture, and you find that governments are injecting money into this. And now really the dilemma is whether, as advocates, do we advocate for a total halt of the extension and the expansion of fish farming, or whether do we then encourage government to say that put then legislations in place that are going to be in line with international standards, so as to ensure that you observe animal welfare. So that is really the challenge that we are confronted with, and actually there's also there are a lot of resources that are channeled towards this type of farming. So those are just some of the things that we are confronted with in the continent, and that we should continuously think about and talk about in us trying to address this issue.
Yeah, I think that's such a good point. I think it's a challenge when the push for nutrition and feeding people is there, and there isn't necessarily the plant-based alternatives that are so easy to come by or can be grown in such a way that are usable. And I think that is a big challenge. I'm not really sure what the answer is. And I think that's why when you talk about improving standards. Indeed, if they are going to be built, at least let's try and get something that goes somewhere towards starting at a level that's not, because what happens is, right, as cheap as it is, it stays that cheap. Like, no, price never wants to increase. So if you can at least bring it in at a level where, like, this is the cheapest, but the standards are a little bit better, people aren't expecting it to be cheaper, you know. That said, when you mentioned international standards, I thought, yeah, there are no standards anywhere. And this is the problem. It's like, international standards. Yeah, do you know what? There's some certification systems that do a bit, like, but welfare is not really predominantly included in those certification systems. So the best of the best is the RSPCA, salmon and trout. That's all they've got species-wise, salmon and trout. To be quite frank, it's not good enough. They have a lot of problems with their salmon farming in the RSPCA. They have a lot of problems with disease. They have a lot of problems with parasites. And they're the best.
I think there's some challenges with Vicky's connection.
So many different carp species. It's quite incredible. So at least, you know, if you were to like predominantly concentrate on tilapia and catfish, I think you can go a long way to creating some standards that could be really, really impactful. And like I said, there are some key things that you can do, like water quality or like stocking density with catfish, that would make a huge difference to these animals' lives.
Thanks for that, Vicky. Colleagues, are there any more questions for Vicky? And for those colleagues that just joined us, thanks for joining us. And I think we'll share Vicky's presentation with colleagues that could not make it on time. So if there are no questions, then thank you, Vicky, for taking our questions and for the great presentation. It was really an honor and a pleasure to have you with us. So colleagues, this concludes our webinar, and thank you all for attending. I hope that we learned, because I certainly learned a lot and enjoyed the presentation. Thank you very much, colleagues.
I'd love to see you all, and I hope to see you in person at some point in the near future. Be nice.
That would be great.
Well. Thanks. Bye.
All right. Thank you. Bye, guys. Bye, colleagues. Bye.